Okay. Now I'm discussing a very important thing, that is, you can see the question that two vectors are inclined at a particular angle theta. Okay, particular angle theta, and you can see using parallelogram law of vector addition, you have to find the magnitude and direction of their resultant. So this is the question. So I have taken two, you can see very well that I have taken over here, that is two vectors over here, P and Q. And another thing that I have taken over here, that is two vectors are inclined at an angle, how much? They are inclined at an angle theta. So this is my angle of inclination of the two vectors. Now what is my need? I want to find the direction and the magnitude of the resultant. So which one is the resultant over here? Our resultant is basically the R vector. So we'll find out the magnitude and the direction of this resultant using simple mathematics. So just what I am doing, try to understand, children, that first of all, I just extend it like this, and to this, I drop a perpendicular from here. So let me name it also so that it will be better for you. That is O, this is A, this is B, and this is C. So over here, I drop a perpendicular from B to this OA extended, and let me name it as N. So children, if this is theta, this will be also theta. Why? Because this is corresponding angle. So these two angles are corresponding angles. So I can say this is also theta. Now another very important thing, you know that magnitude of OC will be equal to magnitude of AB. Why? Because these are the two opposite sides of the parallelogram. Opposite sides of parallelogram, right? So these are the opposite sides of parallelogram. So therefore, we can obviously say, if I consider one of the vector acting above OC and the magnitude of OC is say Q, magnitude of Q, well, let me denote it by only Q. And I denote similarly the magnitude of P as only P. So can't I say that if this is OC is Q, then AB is also Q. And the magnitude of OA, magnitude of the P vector is also P over here. So now I consider the triangle ABN. So children, in triangle ABN, what can I say? Sin theta is equals to BN by AB. So I can obviously say that our AB is Q, therefore sin theta will be equals to BN by Q, and therefore BN will be equals to Q sin theta. Am I clear to all of you? So Bn will be equals to therefore Q sin theta. Okay. So Bn will be therefore equal to Q sin theta, right? So this is a very important thing. Then I move on to this part, that is, if this is Q sin theta, so let me write it over here. Your Bn is Q sin theta. Okay. So next move on to the next part, that is your cos theta. So what will be cos theta? I can obviously write that cos theta will be equals to AN by AB. So AB is Q. So similarly, I can write AN equals to Q cos theta. I hope it is clear to everyone. So you can say, children, this part, that is the AN part, is Q cos theta. So we have got this part, that is one is AN is Q cos theta and BN is Q sin theta. So now I consider the triangle as a whole, this triangle as a whole. Which triangle? I am trying to consider this triangle as a whole. So let me just consider the triangle, this triangle I am considering. This entire triangle, if I try to consider, okay. So I am just shading it for you so that you can understand prominently that which triangle I am trying to consider. Here it is, the total triangle I am trying to consider. So this is the triangle as a whole, if I consider. So what can I get, children? That means in this triangle, I can get that OB square, OB square, because OB is representing the resultant, right? So OB square. So which triangle I'm considering? I'm considering triangle OBN. So in case of this is OB square will be equals to BN square plus I can write ON square, isn't it? So OB square is equals to BN square plus ON square. Now what is Bn? Bn so already I have found out as q sine theta. So I will take q sine theta whole square. So Bn square is equals to q sine theta whole square plus what is On square? What is On? On will be therefore I can write P plus Q cos theta whole square. Because you can see very well here On means OA which is equals to P and plus AN which is equals to Q cos theta. So I can obviously write ON equals to P plus Q cos theta. So this is P plus Q cos theta whole square. And what is OB represented over here? OB is equals to the magnitude of the resultant square. So if I now do the simple calculation, that is q square sine square theta, and this is what you are getting. You are getting over here that is equals to a plus b whole square. So that will be equals to q square sine square theta plus p square plus q square cos square theta plus 2pq cos theta. So what I will get, children? I will write over here for you, that is p square plus q square bracket sine square theta plus cos square theta. So this is sine square theta plus cos square theta plus 2pq cos theta. So from here what you get? You get that magnitude of the resultant square, that will be equals to p square plus q square plus 2pq cos theta. Don't worry, I'll turn the page on so you can copy later. Just understand the proof first. Magnitude of resultant will be therefore root over of p square plus q square plus 2pq cos theta. So this is the, you can say, this is the magnitude of the resultant of the two forces which are inclined at an angle of theta with each other. So this is the magnitude of the resultant. So you can see over here, this was the resultant, and over here, the magnitude of the resultant therefore will be equals to p square plus q square plus 2pq cos theta. Now I want to find out the direction of the resultant. So let me just move on to the this page so that I can find out the direction. So let me draw the parallelogram once again so that it doesn't look cumbersome. So this is one thing and this is the other. If I consider this to be the parallelogram, so over here this was my figure. Okay, so now the resultant was something like this. So here was the resultant. Okay, so this was P, I told you, and this is Q, and this is inclined at an angle theta R. So this is R. And this angle, suppose the resultant makes an angle of phi with the direction of P. So the resultant makes an angle phi with the direction of P. Another thing, we have already seen that we have dropped a perpendicular from here. We have dropped a perpendicular from here. And this perpendicular is something like this. This is the perpendicular. We have dropped from here. So this is equal to theta. So this is also theta and this is Q. So over here, this is your 90 degree, which I already have drawn over here also. So this was my OABC. I have already drawn. So this was my O, this was A, this was B, this was C, and this was N. It's the same diagram I have drawn before. Now, what is the angle made by the resultant? So let me take phi is the angle made by the resultant, with P. Okay, with P vector. Angle made by the resultant, that is the R vector with P vector. Phi is the angle. So what can I say? Tan phi is equals to, therefore I can say, children, that is Bn divided by On. And what is Bn? Bn already we have taken Bn as q sine theta. Hope you remember. And this An was q cos theta. And this is On. So On was what? P plus q cos theta. So I'll write q sine theta divided by P plus q cos theta. So from here you can get the value of phi, that is tan phi is equals to therefore q sine theta divided by P plus q cos theta. So this is the value of tan of phi. So this is the most important part, that phi is the angle made by the resultant with the direction of P vector. Now children, I like to tell you something more. That is, suppose if I consider the angle made by the resultant with Q as beta. So let me write it over here. Here beta is the angle made by r vector with q vector. Okay. So how it will change? Just see. What I will do, children, just let me tell you the approach behind it. Over here, this is my q and this is the q. The q will be represented, or q will be replaced rather by p. So I'll write tan beta will be equal to, just replace the, just interchange the q's and the p's. Interchange the position of q and p. Just you will find that you will get the answer. That is tan beta will be therefore will be equals to p sine theta divided by q plus p cos theta. So if you just interchange the position of p and q, you will get that what is the value of angle made by the resultant with the direction of q. So this phi is the angle made by the resultant with the direction of p. So that is very, very important. So this is, we have learned now to find the angle between the resultant and the two vectors, and also we have also found out that the magnitude of the